Welcome, Edavo students, to today's explainer. We're going to completely unpack section 15.3 of your textbook on software product lines. You know, if you've ever wondered how massive software companies actually manage to build incredibly complex systems for thousands of different clients without starting from scratch every single time, well, you are absolutely in the right place. Today, we're looking at the elegant architecture behind that kind of massive scale. Let's get into it.
Here is our syllabus for today's lecture. 1. Introduction to product lines. 2. Base application components. 3. Frameworks versus product lines. 4. Types of specialization. 5. System configuration methods. And finally, 6. Exam summary and conclusion.
Section 1. Introduction to product lines. Okay, let's dive right in and look at the real pain point of building custom software from scratch, before we introduce the ultimate solution.
Following our rule of defining things first, a software product line is essentially a set of applications with a common architecture and shared components, where each application is specialized to reflect specific customer requirements. What this means in plain English is that we build a family of related applications from one single shared core architecture. We're not reinventing the wheel every time. We just change the tires and the paint job to suit the specific terrain of our customer.
To really ground this, imagine an emergency vehicle dispatch system. A software company might want to sell their dispatch software to the police, the fire department, and the ambulance services. Now, instead of writing 3 entirely separate programs from the ground up, we build one common base program. Then we adapt it. We customize the specific behavior for each independent service. This saves a ton of time, reduces bugs because that core system is heavily tested, and it allows your developers to become domain experts really quickly.
Section 2. Base application components. Moving right along, let's break down what actually goes into creating that core software. Pay close attention here, because this is a major exam focus. You absolutely must be able to list and explain these 3 specific components that make up a base application. First up, we have core components. This is the underlying infrastructure, like the fundamental database connection, that literally never changes, regardless of who the client is. Second, we have configurable components. This is code that stays exactly the same, but it changes its behavior based on specific settings or parameters. For instance, a setting that turns on siren tracking for police, but leaves it switched off for ambulances. And finally, we have specialized domain components. This is entirely custom code that is written or replaced specifically for one unique version of the product. Notice how these 3 layers map out in a concentric structure. Right at the absolute center, you have that unchanging core infrastructure. Wrapped securely around that is the configurable application components layer, which provides all that built-in flexibility. And then, on the very outer edge, is the highly specialized domain components layer, where we inject the unique logic for our end user.
So, just to briefly recap before we move on, our emergency dispatch system uses an unchanging database core. It configures things like GPS updating frequencies depending on the vehicle type, and then it adds specialized custom code for, say, fire department routing, which actually needs to account for the width of massive fire engines on narrow streets.
Section 3. Frameworks versus product lines. Now let's clarify 2 concepts that are heavily tested and, honestly, very often confused by students.
A really common misconception is assuming that product lines are basically just the exact same thing as application frameworks. And it's easy to see why. Both of them support a common architecture, and both require new development to create a specific final system. But they are fundamentally different in how they're used and modified in professional software engineering.
Here is the crucial point, and seriously, mark this down as an exam focus. Frameworks are generic. They help you build, for example, literally any kind of web app. They rely strictly on object-oriented features like inheritance, and you generally do not modify the framework's original source code. Product lines, on the flip side, are domain-specific. They are built for a specific business niche, like printer drivers or medical dispatch. They don't require strict object-oriented rules, and most importantly, developers can completely rewrite, delete, or swap out those application components whenever they need to.
Section 4. Types of specialization. Let's transition into exploring how we actually adapt this core software for a totally new client.
When a new hospital or police precinct buys our software, how exactly do we specialize it? Well, here are the 4 types of specialization you need to memorize. First is platform specialization, adapting the base system to run on Windows versus Mac, where the core functionality stays untouched. Second is environment specialization, adapting to specific hardware, like integrating with encrypted police radios versus standard walkie-talkies. Third is functional specialization, changing features based on the customer type, like how a public library system differs from a university reference library. And finally, process specialization, adapting the software to match a company's specific business processes, such as a centralized ordering system versus a distributed one.
This flow brilliantly illustrates the actual adaptation process step by step. When a brand new client comes in, we first elicit their requirements. Then, we find the closest fit from our existing product instances, and we often renegotiate requirements with the client to keep modifications to an absolute minimum. This saves them money, it saves us time, and then we finally deliver the new instance.
Let's move back to our dispatcher architecture and see how this builds up in practice. In a product line for an emergency dispatcher, we have different architectural layers. At the higher levels, we have components for resource delivery and query management. These interact directly with operator authentication to ensure the right data gets to the exact right place.
Building right on top of that, the system includes standard user interfaces at the very top interaction level. This is entirely tailored for the operators sitting in the call center. A police operator might need a very different dashboard layout compared to a fire brigade dispatcher, but both rely on this highly configurable user interface layer.
Down in the underlying resource management layers, the system handles specific resource policy controls and resource allocation. Think of this as the brain that determines which type of vehicle is allocated based on the emergency. It contains the core logic that knows for sure you do not send a riot van to put out a house fire. By structuring the software line this way, we can swap out just that one policy control module for a new client without having to rebuild the UI or the underlying databases.
Section 5, System Configuration Methods. Let's step into our final technical topic before the summary.
We're focusing on when and how these customizations are actually applied to the software, and this is another massive exam focus. You must know the difference between these two configuration methods. Design time configuration means the software developers actually get their hands dirty. They open up the source code, modify it, adapt components, and compile a brand new version specifically for that customer. Deployment time configuration, however, is completely different. The software is already built and compiled. A consultant or even the customer themselves simply uses a separate configuration tool to flip switches, upload data, and change parameters to customize it, without ever touching a single line of source code.
Notice how deployment time configuration flows here. The configuration planning tool feeds directly into a configuration database. The generic system then simply reads from that database to know exactly how it should behave. The generic system itself is never altered. This is incredibly efficient for software vendors because they only have to maintain one core codebase while selling wildly different configurations to thousands of clients.
Section 6, Exam Summary and Conclusion. Okay, let's wrap up this lecture with a comprehensive summary to really lock in your understanding for the exams.
We've covered a lot of ground, so here is your ultimate cheat sheet for Section 15.3. This distills the absolute most important definitions and facts you must remember. Remember the three parts of a base application: core, configurable, and specialized. Know that frameworks are generic while product lines are domain-specific. Be able to contrast design time source code editing with deployment time tool configuration. And finally, memorize those four types of specialization: platform, environment, functional, and process.
Ultimately, mastering these product lines isn't just an academic exercise or some theory you memorize to pass a test. It is exactly how massive software giants scale their businesses efficiently across the globe. Companies like SAP or Oracle do not write new code every time a Fortune 500 company buys their software. They use highly advanced software product lines and deployment time configurations to roll out enterprise software rapidly and profitably.
As we finish up today's explainer and prepare to move on to component-based software engineering in our next topic, ask yourself a question. How will this approach transform the way you architect your very own commercial programs in the future? When you start building software to sell, will you start from scratch every time, or will you build a product line? Thank you so much for joining me for this Eduvos lecture, and happy studying!